Welcome to solverfy.
So for part A, for path 1, we have that the integral of path 1 for ES would be equal to the negative change in flux, in magnetic flux of B sub 1, divided, with respect to time. And this would be equal to the derivative with respect to time of B sub 1 times A sub 1. This is going to be equal to pi r sub 1 squared multiplied by dB sub 1 with respect to time. We can then say that this is going to be equal to pi times 0.200 meters quantity squared multiplied by negative 8.50 times 10 to the negative third Teslas per second. And we find that this is equaling negative 1.07 times 10 to the negative third volts. For part B, we have path 2, and so we do the exact same calculations. This is going to be equal to negative change of magnetic flux of B sub 2 divided by D with respect to dt, or with respect to time. This would be pi r sub 2 squared multiplied by dB sub 2 with respect to time dt. And this is going to be equal to pi times 0.300 meters quantity squared multiplied by negative 8.50 times 10 to the negative third Teslas per second. And we find that this is equaling negative 2.40 times 10 to the negative third volts. And finally, for part C, we have path 3, and this is just going to be the difference between A and B. So we have path 3 would equal path 1 minus path 2. And this is equaling negative 1.07 times 10 to the negative third volts minus negative 2.4 times 10 to the negative third volts. This is equaling positive 1.33 times 10 to the negative third volts. That is the end of the solution. Thank you for watching.